Welcome to part two. We have just done factoring by grouping, which is when there were four terms. That was just a preface basically to the real thing with quadratics, which is what happens when there's a number in front of x squared, which means you can't do the whole regular as if this wasn't here, what multiplies to 12 and adds up to 13. You start playing that number game, you're going to get the wrong answer. Once again, this is going to be for trinomials. It's called the AC method. It goes by different names some places, but most common, if you take math in college, they'll call it the AC method. The reason for that is actually the very first step we're going to be doing. But first of all, you're going to be factor like this if there are three terms and a does not equal 1. Meaning, once again, you're going to have a number in front. So like this one has a 3, that one has a 10, that one has a 2, that one has a 4. So it's not just the regular what multiplies and what adds. Keep in mind all of this is after a GCF. These first couple on this page do not have a GCF because this is mostly just teaching you how to do it afterwards. It is possible, and on the next sheet of paper I'm going to show you there are some where you can factor out a GCF and then there's just no number in front anymore. So you could do the normal factoring type. But if there is a number in front and there is no greatest common factor, the first step is going to be taking A and multiplying it to C, hence AC method. 3 times 12 is 36. So you're going to do a similar number game for what multiplies to 36 and adds up to 13. So kind of similar what multiplies and adds, but this time it's what multiplies and adds. And some people can get it right away for what multiplies to 36. If not, you can just go through everything that multiplies to 36. So like 1 and 36 multiplies to 36. 2 and 18. 3 and 9. That's not true. 3 and 12. I can do math. 4 and 9. 5 does not go into 36, and 6 goes into it 6 times. After that, it's just going to loop around, so we only have these options. So of all of these, one of them is going to get you 13 somehow. If it doesn't, then that means it's not factorable, but we're not really testing you on not factorable, so most of them it will work. In this case, it looks like 4 and 9 will get you 13. With a 4 plus 9, which means both of these would be positive. A positive 4 and a positive 9 will get you a positive 13. So we will have a 4 and a 9, both of them positive. And this time I'm going to do something a little differently. Let me zoom in a bit. Instead of just doing 4 and 9 like I usually do, I put a 4x and a plus 9x. The reason for this is because what you are about to do is split this 13 into the two numbers we just found. So this 13x is now going to be plus 4x plus 9x. So you split it up into those two things. Whatever it is, we already said 4 and 9 add up to 13, so you're just rewriting this 13 as 4 plus 9. Meanwhile, the 3x squared and the plus 12, they just come down. Don't do anything to them. Like so. Once that is split up, we now have 4 terms. And as we did in the previous video, if there are 4 terms, you can factor by grouping. Now, assuming you chose the correct numbers, this will always be factorable by grouping. You will always be able to factor a GCF out of the first 2 and the last 2, and then the 2 parentheses things will match, and everything will work out perfectly. So let's try it. We'll group these first 2. We'll group these last 2, like so. Then you look for something that goes into 3x squared and 4x. Between 3 and 4, what goes into 3 and also goes into 4? If you're still thinking, you are correct. There is nothing. There is nothing that goes into 3 and 4, so you don't pull out a number. However, they do both have an x, so you can pull out an x. In which case, you have a 3x plus 4 left over. That's a good old-fashioned GCF. What goes into 9 and 12? The answer is 3. 3 goes into 9, and 3 also goes into 12. So pull out a plus 3. 3 times what is 9? 3 times 3 is 9. And then 3 times, plus, bring down the plus. 3 times what is 12? 3 times 4 is 12. And hey, look, not so coincidentally, same parenthesis. As I said, as long as you are choosing the right number, they will always work out to be the same. So you have an x plus 3 and 3x plus 4. And that is factored. Done. Another example problem right here. If you want to try it by yourself, go for it. This one is very much like the previous one. It's just you do the 10 times the 6 equals 60. What multiplies to 60 adds up to negative 19. Split up the middle terms, factored by grouping. So if that's enough to go off of, you can try it. If not, then here we go. 10 times 6 is 60. Negative 19 in the middle. What multiplies to 60 adds up to negative 19? The answer is I have no frickin' idea. So let's see what multiplies to 60. How about 1 and 60? Or 2 and 30? Or 3 and 20? 4 and 15? 5 and 12? 6 and 10? 7 does not. 8 does not. 9 does not. 10 is back where we started. So this is everything. And somehow we're supposed to get 19. I'm noticing this probably would. I think that's the only one. Yeah. And since they are supposed to multiply to positive 60, but at the same time add up to negative 19, that's going to mean that these are both negative. So it will be a minus 4x and a minus 15x. By the way, in case you're wondering, if I put the negative 15 first and then the negative 4, you're going to get the same answer at the end. It doesn't matter. There's no, like, how do you tell which one you put first? It just literally does not matter. So, once again, I'll keep the 10x squared. I keep the plus 6. But this negative 19 is going to be put into negative 4x and a minus 15x. And then you can factor by grouping. And in the first video, I made mention of this. Make sure this negative sign is inside the parenthesis. I have always kept the plus or the minus inside the second parenthesis. Please make sure you are doing the same. In the first parenthesis, 10x squared and 4x. 2 goes into both of these. And an x. 10 divided by 2 is 5. Bring down the minus. 4 divided by 2 is 2. And finally here we come to a negative. If this term right here is negative, you need to pull out a negative number. So then it's just what goes into 15 and 6. It is 3. So you need to pull out a negative 3 because this first term has to match the other one. Remember, these have to match. And if this is positive, this got to be positive too. So pull out a negative 3. And if you pull out a negative 3 from a negative 15, you have a positive left over. But don't forget that that also changes this one. If you pull out a negative from a positive, it will change it negative. A lot of people forget that, and especially like later when they start putting a plus here, it's like, why don't those match anymore? It's because you're pulling a negative, and the negative changes both terms. And now you got a 2x minus 3 and 5x minus 2. There you go. Okay. I have a little bit of time left. I try to keep these under 10 minutes, but I am not going to succeed. But I'll do these last 2 problems. Feel free to pause. Feel free to rewind if you feel like I'm going too fast. But here we go. 4 times 7 is 28. 16 is the middle number. Look for things that multiply to 28. add up to 16. 1 and 28. Maybe it's 2 and 14. 3 does not go into it. 4 goes into it 7 times. 5 does not go into it. 6 does not go into it. 7, and we're back where we started. So that's everything. This one looks like it'll be 2 and 14. 2 plus 14 is 16, so they will both be positive. So 2x, 14x. So this will get split up. Keep the 4x squared plus 2x plus 14x. And then plus 7. 4 terms. Factor by grouping, keeping the plus with it. Here you can pull out a 2x. So pretty much the same up until here. Now I'll start going a bit slower. Pull out a 2x from a 4x squared. 4 divided by 2 is 2. But here, be careful. In the previous video, I always said if the answer is nothing, you're going to put a 1. You bring down the plus, and if you take out a 2x from a 2x, make sure you are putting the plus 1. Because it is technically division. 2x divided by 2x is 1. Or 2x times 1 is 2x. So you do need to have that 1 there. You're always going to get 2 things inside each of these parentheses. Don't just leave it as 2x. That won't make sense. You'll be very confused, and rightfully so. Here, 14 and 7. Pull out a positive 7, and you get 2x plus, same thing. Take a 7 away from a 7. You don't get nothing. You get a 1. So 2x plus 7. And then the 2x plus 1. And finally, 2 times negative 1. And this is just a 1 on top. Luckily, the only things that multiply to 2 are 1 and 2. Yay! It looks like the 2 will be positive and the 1 will be negative. Negative 1 plus 2 is positive 1. So minus 1x plus 2x. So 2x squared minus 1x plus 2x minus 1. Group them puppies. Pull out an x. You got a 2x minus 1. And once again, if the answer is nothing, the answer is 1. What did 2 and 1 have in common? Nothing. There is nothing that goes into both of these. So if the answer is nothing, the answer is 1. What do you pull out? 1. Pull out a plus 1. And yes, you do need to write that. You're pulling out a 1, which does nothing. So you get 2x minus 1. You need to put it to remind yourself that the stuff outside is an x plus 1, not just an x. You have to pull out something, even if it's just a 1. Then you get 2x minus 1. Boom. Done. All right. Check out the back, and we will see. The back just looks like this. Here they are blank, and then I'll put an answer key up. And thank you, Mr. Carter, for your contribution. All right, so just give these a shot on a separate sheet of paper. And here's the answer key to look backwards afterwards, and I'll zoom out. Boom, boom. Boom, boom. Pause is necessary. Have a good one.